So, hello, my dear students. Today, I welcome you all to my physical sciences class. Today, we are going to learn about how we can know about something that is very obvious. Suppose that this is a phone and I drop it, it will fall down. So, we will see why the objects fall down and what is the reason. Okay, so let's start our today's class. Right. So students, here are two pictures, and in these pictures there are some things that you can observe. So is there something that you can observe, students? Yes. Right. So in this picture, I can say you all saying that this glass of milk is falling on the floor. Right. This boy is tossing this ball and this ball is also falling down on the floor. Very good. But students, you might have observed this phenomena in your home, isn't it? Have you all observed this phenomena? Yes? Right. Okay. Very good, students. So, you might be thinking that what might be the reason that this ball is dropping down or this milk is falling down? Why only down? Why can't it go up? So, there are some specific reasons to it. Okay. So, let's start our today's class. So, here we know out there is an acceleration of gravity, right? The acceleration of gravity is the acceleration experienced, right? It is basically an acceleration that is experienced by an object when a force is acting upon it. And what is the force acting upon it? The force of gravity. The force of gravity applied by the earth. Right, students? So now you know why the objects fall down? Yes? Okay, so it falls down basically due to gravity. And what is acceleration due to gravity? Acceleration due to gravity, it is just an acceleration experienced by an object when the force acting upon it is by the gravity. Okay, very good. So now students, you might have heard about one person and the name of that person is Newton, Charles Newton. Okay, so I will write it here. Right, Newton. So this Newton fellow, what he was doing, okay, I'll just erase it, right? So this Newton, he was one day sitting on in the shade of a tree, right? And then suddenly this apple came and fell on his head, right? So it is said that when Newton was sitting under a tree, an apple fell on him, right? And the fall of the apple made Newton start thinking. He started to think. And what he thought? He thought that if Earth can attract some object towards it, there is also the moon. The moon should also attract that object, right? And the force should be the same, right? And he then thought that the force applied should be the same, right? Okay, and then he came up with the concept of gravity, right? So basically, here are two questions that I have brought for you, right? The first question says that what is acceleration due to gravity, right? Can you answer this question? Yes, students, can you answer this question? What is acceleration due to gravity? Right. So acceleration due to gravity is the acceleration experienced by an object, right? It is basically an acceleration experienced by an object when the force of gravity is applied to it, right? And what is gravitational force? Gravitational force is that force which gravitational force is that force which the earth applies or any heavenly bodies applies to any body, anything to make it attract towards itself, right? So that is the gravitation force, right? Here in this case of earth, we will say that earth applies a force, right? And that force produces an acceleration in the bodies, and that acceleration is called as acceleration due to gravity, which is denoted by G. Okay, right. So students, now let's proceed to our next module, right? So students, can you see in this picture, there is some things happening here. Can you observe this? Yes? Okay. I see you all saying that different planets are moving around in their orbits. Okay students, very good. Now dear students, just tell me that these things are moving around in a circular path, in a very fixed path, right? Why only circular? Why not straight? Right? Okay, right. Let's think about it. So I am just giving you 2 seconds to think about it. Okay, 2 seconds is not enough. Okay, let's take 30 seconds. I'll wait for 30 seconds for your responses. Yes, my dear students. Now you might have done an activity where you would have just tied a rope and started it swinging like this. As this girl is swinging in this picture, you can see that this bob is rotating in a circular direction, isn't it? This bob is rotating in a circular direction. But the moment this string breaks, right? The moment this string breaks, this bob travels in a straight line, in a tangential manner. So similar is the case with this also, right? So let's learn about this. So the moon, let's see about the motion of moon. Okay, the motion of moon around the earth, it is due to the centripetal force. What type of force? It is the centripetal force, right? And centripetal force is provided by the force of attraction of the earth, right? The earth is attracting the moon, and that attraction provides a force, and that force is called as what? That force is called as centripetal force, right? And if it was not for such forces, then what would happen? Then the moon would have flown just right past us, right? In a straight line. Okay, students? Now do you realize what is the importance of gravity? Okay, right. Now, students, there is a question for you. So there are two friends, Bittu and Suman, right? And they are sitting besides each other, right? And you tell me that they might be also attracting, isn't it? I said that gravitation is between two bodies. So is it that Bittu and Suman are attracting each other? Why are they not moving towards each other? This is a very important question. So can you think about this question, students? Yes? Okay? Right. So here, as per this question, we are seeing that there are two individuals. First one is Bittu. Let's name him B. And then there is another person, another student. Let's name him S or Suman, right? So obviously he is also attracting Suman, and Suman is also attracting Bittu because they have body and they have mass, right? But the thing is that they both are sitting on earth, right? They both are on earth, and that's why what is happening, the force of attraction between these two fellows is very less as compared to the force between these two persons, earth and these persons, right? This person is also getting attracted by earth, and this person is also getting attracted by earth. So this force is bigger, right? This force is bigger. That's why he is not attracted towards Suman, right? Anyhow, as his mass is also very less, so what happened, the gravitational force will be less, right? Now there is one more question for you. So gravitation is which type of force? It is a strong force, it is a weak force, it is a moderate force, or it is all of the above? You have to answer it. Okay, so it is basically a weak force, right? Very good, students. Now my dear students, let's observe this thing, right? As we talked about Bittu and Suman in our previous example, so here you can see that there are two bodies, body 1 M1 and there is body 2 M2, right? Now what is happening, this body is also applying some attractive force towards M2, and this force M2 body is also applying some attractive force towards M1, right? So let's denote this by F1 and let's denote the force applied by M2 by F2. Okay, right, very good. Now you see this is also a force, isn't it? So what will happen? This F1 is equal to F2, right? And this will equals to what? This will be equal to G. See here, G, it is a universal gravitation constant, right? And then M1 M2 by R square. So let's derive how this formula come, right? Let's try to derive this equation. Okay, students? Yes, you all are with me? Okay. Now let's derive this equation. Okay, see here, by the law of universal gravitation, Newton gave a law, and that law was of universal law of gravitation. That law is called as universal law of gravitation, and it was given by who? It was given by Newton, right? And by the Newton's second law, force is equal to what? F is equal to mg. And by the universal law of gravitation, force equals to gmm by r square, right? Now see, we will drive an equation between g, that is acceleration due to gravity, and universal gravitation constant, right? So F equals to mg and F is equals to gmm by r square, right? So let's try to equate this, okay? So F equals to mg and F equals to gmm by r square. Then we can say that mg equals to gmm by r square, isn't it? We can come here. Yes. Okay, right. So we can derive this, right? And now it is just a matter of rearranging, isn't it? We can just rearrange it, or we can do what? We can just cut small m. Now what we will get? We will get g equals to gm by r square. So let see this small g, what it represents? It represents acceleration due to gravity, right? This capital G represents universal gravitational constant, right? And this r represents the radius of earth, right, which is approximately equals to 40,000 kilometers, right? The radius of earth is approximately around 40,000 kilometers. Very good, students. Now you see, what is gravitation? So we can calculate the gravitational force by the help of this expression, and this expression is F equals to gmm by r square, right? Very good. So what is the value of g? What should be the value of g? The value of g, it is around 6.674 into 10 to the power minus 11, right? Okay. Yes, right. Very good, students. Is there any problem till here? Okay, right. So let's find out an equation. Let's try to solve a numerical. So let's try to find out what is the force of attraction between you and your friend who are sitting 10 meters apart. Okay. So we will try to find out for force. F equals to g m m by r squared. Right. Okay. Right. So let's suppose, let's take your weight as 10 kg and weight of your friend as also 10 kg, right? Just for the sake of simplicity. So we can calculate g 10 into 10 divided by 10, right? So it will cut out. So what we will be left with? We will left with 6.674 into 10 to the power minus 10, right, kg meter per second, or we can say Newton, right? Okay, 6.67 into 10 to the power minus 10 Newton. Understood? Is there any problem till here, students? Okay, so we have completed our today's module. So let's quickly revise what we have learned. Okay, right. So students, today we have learnt about gravitation, and now let's quickly answer a few questions. Okay. So differentiate between gravity and gravitation. What is gravity and what is gravitation? So gravitation is basically what? Gravitation is the force of attraction. Gravitation is the force of attraction between two bodies, right? Okay, right? It is the force of attraction between the two bodies, and gravity we can say it is the force of attraction between earth and some other object. Okay, like we are sitting on earth, then what we are facing? We are facing gravity, right? Okay, so what is the relation between small g and capital G? Who will tell me? Yes, tell me. Anyone who can say that? No? Okay, let's try to find out, right? By the universal law of gravitation that Newton gave, he gave what? F equals to G capital M small m by r squared, right? And F is also equals to mg, right? So let's cut this m is cancelled out, right? So now G equals to what? Capital G capital M by r squared. So this is the required formula, right? So explain the revolution of the planets. Who will tell? Okay. So basically you see the revolution of planets, okay, the revolution of planets occurs because of the gravitation, right? The revolution of planets occur because of the gravitation, right? And how do we define gravity? Yes. How can we define gravity? Right. So the force of gravity is the force applied by an object, right? The force of gravity is the force applied by a body and an object, right? Now let's try to recall what was the Newton's story, right? So basically what happened, one day Newton was sitting in a garden under an apple tree for shade. Then what happened? An apple fell on his head, right? And then Newton started to think, okay, why this apple has fallen on my head? Why not it has gone towards the moon, right? Because the forces applied by the earth is also the force applied by the moon, right? So that's why he came to the answer that no, there is a force called as gravity, right? And that gravity attracts something towards it, right? And it attracts with an acceleration. It pulls an object with an acceleration that we say acceleration due to gravity, right? Yes, students? Is this topic clear to you? Yes? Okay, very good. Now, there is one homework for you. So what you need to do, you need to describe how the force of gravitation between the two objects change, right? You need to describe how does the force of gravitation between the two objects change when the distance between them is reduced to half, right? Okay, you will do this question at your home, right? I can just give you a little bit of hint. It has to deal with the Newton's universal law of gravitation, that is F equals to G m m by r squared. So this is the hint that I have given you, and working on that hint you have to complete this homework. Okay students, very good. Now this is all for today's class. Thank you.